Right, we're going to be working on the second set of exercises for Unit 3 tonight. And I'm going to scroll down here just to see which ones we're working on. And that would be this set of exercises here, which is exercises 8, 11, and 12. All three of these do deal with objects and classes, and that's the main focus of those. And in the book, the first exercise is number 8, and this one says as follows. Assume that a gallon of paint covers about 350 square feet of wall space. Create an application with a main method that prompts the user for length, width, and height of a rectangular room. Pass these three values to a method that does the following. Calculates the wall area for the room, passes the calculated wall area to another method that calculates and returns the number of gallons of paint needed, displays the number of gallons needed, then computes the price based on a paint price of $32 a gallon, assuming that the painter can buy any fraction of a gallon of paint at the same price as a whole gallon. Right? This is one of those stipulations, because the reason the author puts that in, by the way, is like, well, you can't buy, 3.6 gallons. I can buy 3 gallons and 3 quarts, right? That's really how it sells. But we're not worried about that piece. We're just looking, like, if he could buy it exactly the amount they need, we're going to allow that. It's what this is saying. And finally, that method is going to return the price to the main method. The main method will then display the final price. For example, the cost to paint a 15 by 20 room with 10-foot ceilings is $64. And this is a sample value that we're going to put in and try to make sure that our thing is working correctly. All right, so we got a bunch of stuff to do here. The first thing I'm noticing is that it's going to be called Paint Calculator, so I may as well just copy that, because that's what my first file is going to be called. So I'm going to jump over to Eclipse to do my work today. It's okay whichever IDE you're using, but that's the one that I'm demonstrating. So I'm going to close all my previous work here. And then over here in the Package Explorer on the left-hand side, I'm going to go ahead and I'm going to create a new project for just the second set of Chapter 3 exercises. I'm going to call this Chapter 3, Part 2. And all that's doing is creating a construct here in the Package Explorer where all the files will go and all the code. I'm expanding the triangle now, and I'm going to the source folder. I'm going to right-click that source folder, and I'm going to create a new class file. I'm going to call this what I copied from the book, which is Paint Calculator. And yes, we will go ahead and automatically add the main method to the program. All right. So there is the beginning part of our application. Now, I'm thinking about the directives that we were given, and I want to move the Notepad++ out of the way here. And there's a lot going on and a lot we have to think about. However, we have to start with the fact that we are going to create a separate class file to do some of our work here. So let's talk about how that's going to happen. And actually, now that I'm thinking about this is not one of those exercises, is it? No, it's not. Okay, this one uses a method, so I apologize right there. So this is not objects and classes, not objects and classes. This demos methods, by the way. But this one is a little bit more involved than some of the ones that you guys have dealt with so far. The first thing I did here is that we are going to prompt the user for information, right? So that tells me right away that inside this main method somewhere, I'm going to need a scanner. So why don't we just take care of that business right away? I'm just going to type the class name scanner, and I want you guys to notice that it underlined red. I'm going to use the trick. As long as my cursor is at the end of that underlined word, I can press the Control key and the space bar, and it automatically adds the library. Then I'm going to finish my statement. I'm going to call my scanner input, and then we'll say new scanner, and then the command that goes inside the parens is system.in. And this is pretty standard. All right. We're asked by the instructions, and I'll just pull those up on the screen. Create an application with a main method that prompts the user for the length, width, and height of a rectangular room. So now we can actually go directly to those things. We don't have to wait to do it because, that's a pretty simple action. And so if we were to get this information from a user, we might do something like this. So some people would think, well, why don't we create a double? And yes, I'm using doubles on purpose because it is possible for a room to be like, 9.5 feet tall. So I want to be able to do decimal numbers. And I could declare height. I could declare width, spelled correctly. And I could declare length, all in one statement. And if I wanted, I could also apply values to them directly. That's totally a doable thing. However, that's not the approach I'm going to use. Although some of you may have used that approach. And some of you may have declared these separately. Some of you may declare them all in one line like this. Either way is fine. I'm going to use a different approach, which is to create the variables on the fly, so to speak. And so I'm actually going to declare them as I'm feeding them into the variable. So I'm going to say if the height of the room is going to be equal to the input. Well, normally I would say next double here, right? And it auto detects that, but I forgot to prompt my user, right? So I got that, system.out.println, and now what are we going to say here? Enter the height of the room. All right, so that's the first part. And then this is declared here, double height is declared here, and grabs information immediately from the keyboard. This is going to be a repeating process, so we're going to grab the height, and then we're going to ask for the width, and then we're just going to change the variable declaration here. And then once again, let's not reinvent the wheel. Let's just paste that in, and now we're going to put in length. Okay, and just make sure everything's all matched up. So with this here alone, we have now grabbed those particular things. Now, if you read the next set of instructions, and I'm going to get rid of this piece if you don't mind, in the assignment. So create an application with a main method that prompts the users for length, width, height of a rectangular room. Done. Crossed off the list. That's how you should look at this. Next thing it says is pass these 3 values to a method that does the following. Okay, so the next thing I have to think about is if I'm going to pass this to another method, what is it going to do? It calculates the wall area, calculates, returns the number of gallons, displays the number of gallons, computes the price, returns the price to the main method. So ultimately what it's really doing is it's calculating the cost of all the stuff that we're doing. Okay, so I think that a really good name for it might be, how about calculate cost? And so I'm going to create a method here called exactly that. And I want to kind of show you kind of a neat trick here. So the one thing I could do is I could come down here and I could type public static, and it's supposed to return something. In fact, it's going to return the total amount, so that would return a double, and then I would call it calc cost with parentheses and curly brackets and all that stuff. Okay, however, that's if I manually create it, and some of you will do it that way, and that's absolutely fine. An experienced programmer might do it like this, though, and I'm just going to show you this trick right off the bat. Is an experienced programmer would just actually create it here with the values of height, width, and length being sent directly into it. So this is calling a method right here. But it's recognizing with the red underline here, there's no method. Now I want you to notice what this is doing here. It says create method, calculate cost. It will create it for me. But the fun thing about this, by the way, is yes, it can be pretty intelligent and create it for you. But if you're planning even farther ahead, some people will say, well, it says to return a value. And if you're going to return a value, I have to have somewhere to put it. So I'm creating a double to hold the value it's going to return, calling a method that doesn't exist yet. And then now that it's going to auto suggest a fix here for me, I want you to watch the magic of what Eclipse does for us. It will automatically create the method with all the right stuff put into it. It is setting it for private. Now, normally, I most of the stuff that we do in this class will be public, right? But private just means that it's only accessible by this application and nothing outside of this application. That may or may not be what you want. I'm going to err on the side of caution and just make it public in my case. Notice that it did put in the keyword static. It means this method's not going to change. It's going to return a value of double, and then gave us the name, which we predetermined, and then it realized that we're sending in 3 doubles in the order of height, width, and length. Now, I'm not a huge fan, by the way, of using the same variable names in the main program body and then inside of a method. I was taught it was bad practice. So I'm going to change these names to just single letter abbreviations of the same thing. So H, W, and L, height, width, and length. And they do have to go in the same order that they're presented. But now inside this new method, instead of using these names, we really are declaring new variables. So these will be used for all the calculations right inside this method. We will be returning a value. We haven't determined what that value is yet, but we are going to do that. Okay. I'm going to now go back to the instruction set and read. Okay, so I'm going to read. It says, we're going to pass these 3 values to a method that does the following. We already created it. Calculates the wall area for the room. All right, you know what? Let's just take these one at a time. So I'm going to come back to my method now, and I'm just going to create a blank line here. And if I calculate the wall area, it's going to be, some multiplications and additions and whatever. But whatever I do, I want to have a way to store it. Like whatever answer I get as a wall area amount, I want to be able to put it somewhere. Since I'm going to be doing all my math with height, width, and length with doubles, the result will likely be a double also. So the data type I'm going to select here is going to be a double. So I'm going to start by creating a variable that's going to hold the answer for the calculation I'm about to do. So I'm going to create a variable called wall area. And then now I need to determine, how do I get to a wall area? All right, so if you think about the shape of a room has a height and a width, right? And if I look at and really kind of a drawing is helpful here. Let me see if I can kind of do this on the screen without being too weird about it. But if I think of like a wall being like this, right? And then if I was to like kind of simulate kind of the dimensions of a room, this is going to be really bad art, by the way. I'm trying to use these zoom drawing tools to do it, which is kind of interesting. So if you can picture, the dimensions of a room, in 3-dimensional space, right? And what happens in this 3-dimensional space, right? So down here is the floor, this is the ceiling, wall, 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 right? We can kind of assume in a rectangular room that the 2 walls that are opposite each other are going to have the same dimensions. So those are going to have a height and a width. And so the first thing that we can put in dimension-wise here is we can say height times width. We also recognize the fact that these opposite walls have the same dimension. So, it's provided the room is truly rectangular, right? And so we can just multiply height and width times 2. So height times width would give us 1 wall's area, multiply it by 2, and it gives us both that wall and the opposite wall. So it gives us this wall and this wall, all right? Now I'm just going to put all of this into parentheses because I'm going to add something to it, right? And what I'm going to add to it is the calculation for the other two walls. So these two walls. Well, if this is the height's going to be true for the other wall, but this dimension would then become the length of the room. And so if I want to get the area of this wall segment here, I'm going to multiply length times height. And once again, this wall is replicated on the other side of the room, so I double it. So this calculation is going to be height times length times 2. And then at the end, we are going to put our semicolon. All right, so that's already one of the things crossed off the list. Believe it or not, here we have calculated it. We have calculated the wall area given what the user has put in. So let's move on to the next directive. So this one is crossed off the list. I'm going to get rid of the drawing. Next one says, it passes the calculated wall area to another method that calculates and returns the number of gallons of paint needed. And so the second thing that we're going to do is have another method to calculate the number of gallons. Okay, so let's do this piece now. So the way that my brain thinks about this, and right now I'm going to comment out this return statement. Yes, it throws a red line underneath, but I'm going to think about it like this. We need to determine the number of gallons needed, and we're going to send it off to another method, which is going to return the number to us. So once again, we need a spot to put the returned value. And the number that's going to come back to us are the number of gallons needed. That's what we're going to store here. We're going to let a different method do the calculation that we're going to call calc gallons, and we're going to send into it the wall area that we just calculated. It's going to take that wall area, do some math, return back to this spot a number that we're going to store here. Okay. Now, the same way that we did before, this is needing a method created, so we're going to let this create it automatically. And see, the beauty of this is it doesn't make any mistakes, except for the fact that I prefer that you set this public, but not a big deal. Okay. Now, let's talk about what it would take to actually calculate the gallons needed. Well, we were given some basic information. Okay. All right. So somewhere here, assume that a gallon of paint covers about 350 square feet of wall space. So we're going to assume that when somebody types in here how big the height of the room is, they're going to do it in feet. So how tall is your room? 8 feet is a real common answer. All right. Or 8.5 or 8.5 feet. All right. So we're assuming that. And then the calculation, once again, is the wall area, right? So however many total square feet we come up with, and we know that 350 square feet can be covered by 1 gallon. Really, all we have to do is determine or take this wall area and divide it by 350 to get the amount needed. I am going to change the name of this variable here for the same reason I did before. I don't like using the same names. It's just a habit I learned long ago. And then I could do some math here. So I could do it like this. I could create a variable called like answer, for example, and then I could take the wall area and divide by 350. And then I could return the answer back. That's one way you could do it. Experience programs would say, why bother storing the variable? It's a value you just use temporarily and then it goes away. And that is, really the way that a pro would do this is they would just directly return the calculation. So they would just put the calculation here directly. They wouldn't even bother storing it in the variable. No need for it, by the way.
Hi, can I interrupt you?
Absolutely. Please, Dennis.
Just a second ago, if you where you had the redundant variable and it was listed twice, you listed it above and then you returned it. The IDE gives you a message saying redundant. At least my IntelliJ says that it's a redundant value listed twice. So
Right.
how would, and if you were going to calculate, use it, and then return it, how would you combine it into one statement to return it? And can you return and calculate? Can
Yep.
you
You can
do
return
that
and calculate at the same time.
at the same time?
You can. And that's exactly what I'm demonstrating here, Dennis. But the other aspect of it, where you're using these names here, I've never been a fan because if you don't structure your code right, those variables can get confused. Like if you forget a curly bracket, it can break things really bad. If you
Right.
use different names in each location, it just makes it clearer. And I'll be real frank, that's a preference, not a requirement.
Okay.
Now the problem that you're talking about, I'm going to guess that maybe you have an incomplete statement or something's not closed, you're missing something, that maybe it's generating that. But you are also using the JetBrains IDE, which is a little different.
So I declared the value like for the input, and then I return it right after that in a method that I did. And
Okay.
it tells me that just the variable name is the exact terminology is it says data one, which is I call it, is redundant.
Okay. I'll tell you what, Dennis, let me build the rest of this because we're pretty close to done already.
Okay.
And then we'll take a look at yours and see what's going on. And then we'll compare and contrast is really kind of a good way to do it.
Okay, cool.
All right. So um, going back here now, so we created this method, which is doing that work and then sending back the next value we need for calculation. But I'm thinking in terms of the person that's looking at this and trying to get certain pieces of information. So one thing that you might want to do is tell the person, for example, how much wall area you have in an output statement. So you might say something like, your room has a wall area of, and then we'll concatenate to that the wall area that we calculated and maybe append to it square feet so we know what, parameters we're working with. It. All right. Now we send this method off. It calculates how many gallons we need, does the math, and sends it back. Now, what are we going to do with that piece? Well, once again, we're going to do an output statement. So I'm going to just get this started here and say the gallons needed, the number that we just calculated, and I'm not putting it inside of quotes, by the way. Okay, so that number that we came back with, we're going to say, 42 gallons are needed to paint the room. So that's another aspect of what was required of us, is to come up with that piece. So we calculated the wall area, showed it to the user. We calculated the gallons needed, and now we're showing it to the user. The next thing that it asked us to do is to determine that at a price of $32 per gallon, how much the total cost is, which ultimately is what we want to show a person. And so here, what we could return instead of 0 is we could return the total cost. And I'm just going to call it total. And that's a variable I haven't created yet, but I'm going to go ahead and create it. So I'm going to create a double called total, which is going to be equal to the gallons needed, number we calculated, times $32 a gallon. That'll get stored in total. The value total would be returned. And then to kind of go back to our previous conversation, could I just take this and put it in place of total? Yes, by the way, you totally could. In fact, I won't in this circumstance, just to demonstrate the difference. You can hard code an equation right into the return statement, or you can return a variable that's been predetermined. Either way works just fine. This value here ends up here, which then goes here. This value that we're calculating and we're putting here, it's going to go to here and then return here. And so to finish our program, believe it or not, this is almost done. The last thing we need to do is just a simple system out print line that just says your total cost at $32 dollars per gallon is, and here's, if you want, you can go into the print formatting command if that's what you want to do. I'm fine with that. It's good practice. This is a good spot for it, dollars and cents. I'm just going to do a straight up output because I really kind of don't care, frankly, at this point. But if you want to make yours look pretty, make yours look pretty. Now, just to show you all the code here really quick before I run it. All right. So once again, we have our scanner. We're prompting for the height, width, length of the room. We're then sending it off to this other method, which will return the total cost. That other method receives those three values, calculates the wall area, puts a message on the screen, calculates the gallons needed by going to another method, right? Sending in that value, returning it, which ends up here. Then we output that to the screen. Then we take that value that we calculated, gallons needed, multiply by 32 to get the total. Then the total is returned back here, stored in cost. Then we are able to put it on the screen. You want to format it in the aftermath? Go for it. In fact, you can put a dollar sign here if you want to get all particular about it. All right, I'm going to go ahead and save this, folks, and I'm going to run it, and then I'll show you the successful operation of this program. All right, my console is kind of condensed here, so let's go ahead and take a look. They did give us some numbers to work with, so I want to take those numbers. So a 15 by 20 foot room with 10 foot ceilings. Okay, 15 by 20. The height of the room is 10 feet. The width of the room is, I forgot the numbers already, 15 by 20. 15. The length of the room is 20. And if we did things right, we're hoping that the numbers that we get here are the same. So your room has a wall area of 700 square feet. 2 gallons are needed to paint the room. Your total cost at $32 a gallon is $64. And that does match up with what they have here. That was their example. Now that worked out perfectly. So somebody sat down and figured out, well, that's great if it's 10, 15, and 20, and it works out perfectly that you need exactly 2 gallons. Very rare in painting, by the way. One thing I did notice is that my entries were coming down in the line below. So you might want to change your print lines, by the way, to prints if you prefer the cursor stay on the same line, by the way. But I'm going to try a different set of numbers here on the next run. So let's try a different set of numbers. And so I'll think of maybe a room in my house here where I have 9 foot ceilings in my place. And I have one room that's 8.5 by 14.25. And so that is 409 square feet of wall space. And that's 1.17 gallons that are needed. And that comes out with a cost of $37.44. And now I could verify that. And, normally what I would do is I would pull out a calculator and then type in the numbers and make sure that those calculations are correct. I'm assuming they're correct, but this is how the program should operate. All right.
I took it as they wanted you to round it to the next gallon.
Yeah. See, and that, Dennis, that's normally where my lecture goes. Okay. On this thing too, because the reality is, they did give you that little tidbit, and you can read it the wrong way. Assuming the painter can buy any fraction of a gallon of paint, right. Price is a whole gallon, which is not the case, by the way, right? It's quarts, gallons, and 5 gallons is how paint is sold. And so, of course, you get discounts the bigger the volume. And of course, usually if you're a homeowner and you paint a room, it's not a bad idea to have extra just in case something happens and you need to repaint or touch up or whatever. But some people will also argue that these calculations are flawed because who says we can't paint the ceiling the same color? Okay, well, that's one thing, right? So you could add in calculation for the ceiling if you want. The other thing that you might want to consider is if you do come out with 1.17 gallons, then you could start to do some of the math that we learned in previous chapters, where you could start doing modulus division and figure out how much is left over. And so really, if you were looking at 1.17 gallons, what would be the smart buy? 1 gallon and 1/4, right? That's what you really have to buy, right? And then, and in some cases, some people would say, I would just go ahead and buy 2 gallons. I'd rather play it safe. $32 is not a lot to spend to have a little peace of mind if I screw up or spill paint or whatever, right? Or I need to repaint the room. So, I mean, you can get into those nitty gritty details, but this is the solution for this one based on the way it's written in the book. All right, we're back from break and we're going to continue our work. We're going to exercise number 11 now. This one does have 2 parts. The first part is creating a class file, and the second part is doing a test of the class file, which is kind of the typical pattern, at least in the early parts of the object-oriented programming in this chapter. So this is kind of the technique the author uses. So it says, create a class named Sandwich. Data fields include a string for the main ingredient, such as tuna, a string for bread type, such as wheat, and a double for price, such as $4.99. Include methods to get and set values for each of these fields. Save the class as sandwich.java. All right, so let's start with the fact that it's going to be called sandwich.java, and let's go back over to our coding tool here. And inside the part 2 package here, I'm going to go ahead and in the source folder create a new class file. This one is going to be called Sandwich. This will not include a main method because we are creating a class that will be used as the blueprint to create other objects. So there's no reason to run any code. We're just setting up the parameters for an object. So I'm going to go ahead and click finish on this, and this just creates an empty class called Sandwich. Now, when they refer to data fields, so in the exercise description here, they said create data fields for the main ingredient, the bread type, and the price. So I'm going to do that just like this, folks. And inside the class, I'm going to create what we call private variables, and they need to be private so that they cannot be changed by objects outside of this object. So once we create it, you can't just, once I create a tuna on rye, I can't go making it a salami on wheat, so you can't just change it on the fly. So once it's in there, it's in there. The first one I'm going to create is going to be called main ingredient. And that's like the stuff you put in the sandwich, like the tuna, for example, or salami. Then I'm going to create another private variable. This one will also be a string, and this one will be what type of bread we're going to have. So we're going to have a bread type. Now, I'm not presetting any of these values, I hope you notice. So I won't have a default bread type or a default ingredient. Those will all be picked. And I also won't have a default price either, but I will create a variable, a double, that will hold that. All right, so those are the data fields. Now, it's common when we create a class file like this that the data fields are listed at the top. All right. The next common thing to do is to, create all the things that allow us to manipulate these objects within the class file. So this is where it gets a little weird. So I just want to talk through this with you really quick. So the first thing says, include methods to get and set values for each of these fields. So this is a really common technique, and I'm going to show you how to code it, and then I'm going to show you some magic, basically, which is kind of fun, and another reason why we use a program like Eclipse, by the way. Now, we got to get these getters and setters in here. This is kind of the shortcut thing, and that would be the ability, basically, within our program to allow something from outside this class file to individually control each one of these. And setting would be to set the main ingredient to be something, and getting would be returning that value back to the program from where we're calling it. Okay, and those are very useful functions. So we're going to begin by just individually creating these. So usually these methods will be public because we're going to, if you heard how I said that, we're calling it from outside the class file to allow it to happen. We're not going to be returning anything for most of these. So for example, if I'm going to set the main ingredient, I really don't need to return a value because I'm just setting it. So what will I set it with? Well, a string that will be sent externally to this spot where we will set, again, the main ingredient. And then inside a set of curly brackets here, we will do the work. We will use this magic keyword called this. And this is one of those really weird keywords. And we had an equivalent in Python. So those of you taking Python will have a connecting piece. Do you guys remember what it's called in Python?
Is that the self method?
Self, correct. In Python, we say self. In Java, we say this. And the interesting thing is most languages use this. All this means is it's self-referring back to itself. So which main ingredient? This main ingredient, the one we're currently talking about. That's what it refers to. It's a self-referring declaration. A little bit weird to think about, but when you see it in action, it makes a whole lot more sense. And so we're just going to set the main ingredient within this object to the main ingredient that we're sending from externally. Okay. The other thing that we'll do is by setting it, we might also want to have the ability to return that value as well. So we would do something like this. We would say public string because we're returning it. And instead of saying set main ingredient, we will say get main ingredient. All right. That doesn't require any values to be sent in. We're just pulling values back. And what we're going to do in this circumstance is we're just going to return a value. What are we going to return? Well, whatever the main ingredient is, that's what we're returning. Somebody wants to know what the main ingredient is? Well, here it is. So for as silly as that sounds, we can set the value externally so we can send in a value to assign it. And then we can call the get method to return that value back to where we're calling it from. So we can use it for calculations or displaying or whatever we need to do. Okay. And so for each one of these variables, we would go through the process of creating setters and getters. Set the value in the object, retrieve the value from the object. This is such a common activity inside of Java when you're dealing with class files, whenever you set data types at the top, that guess what? Eclipse has a tool that does this automatically. And this is kind of like $1 million tool, folks, and $1 million tip, by the way. So you can go through the process of laboriously creating these manually. Or, I'm going to let the tool do the work. We can do what professional programmers do, is they right click. And there's a tool that we're going to, there was the right click. And we are looking, within these menus, and sometimes I have to remind myself where it is, but it's in this right-click menu called Source. And as you scroll through this list here, I want you to notice this option right here. So this is a very common activity in Java programming, is to generate getters and setters for all of your data fields. And you can do it manually, just like I was doing it. And sometimes you need to in order to set certain aspects. But the moment that Eclipse recognizes that you've set private data fields like this, you can click this little button and which data fields do you want to set them for? All of them. And then just say, okay. And you can choose whether they're public, protected. We want these to be public so they can be accessed externally. So I'm just going to click okay. And then I just want to show you Eclipse did all the work for me. And more beautifully, it's perfectly correct syntactically. It absolutely will work. And you'll notice that the first couple are the same ones that I was doing. It did the same thing for the bread type. It's got a get, right? A get and a set. For price, it's got a get or a set. And for some reason, it put this down at the bottom. I'm not sure why. It's probably where I clicked before I did the work. Oops. That should be at the top. But it's kind of a crazy powerful thing when you start to think about what just happened here is I'm using the simple declaration in this program of just declaring what those types are, doing a right click. I'm just going to show you where it is again. And then you go over here and generate getters and setters. And I want you to notice there's other things here too, right, that you can automatically implement, which are very um, common, by the way, and automatically generate the pieces that you need without doing a whole bunch of coding and then worrying, is your syntax correct? Now, is this cheating? No, it's not cheating, right? This is what the tool does. What's more important is to understand how it works and then how to implement it in the program. So this part of our work is complete. We can not run this program, and I want you to keep that in mind because there's no main method here, right? This is a class file. This is the blueprint for all the objects that will be created, for all the sandwiches we're going to make. Every sandwich we make has got different bread, different ingredients, and a different price. And if I create another instance of that sandwich, even if it has the same ingredients as the previous sandwich, it is still a unique sandwich. It's like going to McDonald's and say, I have a hamburger, I'll have a hamburger, I'll have a hamburger, right? All three of them are basically same bread, same meat, same price, but they are three unique hamburgers, despite the fact that their attributes or their data fields are the same. They still exist as unique entities. And that's really the hard part of this to probably explain to people that are new to object-oriented programming is that concept that you can have things that are created from this blueprint that on paper at least are functionally identical, but in reality are still unique entities despite their similarities. It's kind of like twins coming from the same mom, right? You might even name them the same way, but they're still unique individuals. Doesn't matter how much alike they look, they're still unique individuals regardless. All right, so that's a class file right there, folks. I'm going to save this. Now, I want you to notice I can't run this. So if I hit the run button, it's not going to do anything. Oh, it's trying to run the other program. Well, great. That's not what we want. So it's looking for a program to run and it can't run anything. However, I can compile this. I do know that because there's no yellow or red highlights here, I don't have any problems. But I could, instead of running it, I could debug. And notice it's trying to not debug this program. You guys noticing that? It's because I wasn't on that tab. It's trying to run this one. But if I debug, see, once again, it's picking the wrong file. I want to debug sandwich, but it's not coming up, right? So I can try to hit that play button again. It goes right back. So it's not going to let me do it. So I have to go off the highlights on this predominantly to make sure I have no errors. But if we are error free, we're ready to move to part two. And part two is this.
So real quick, Ty.
Yes.
So going back to the private, because obviously it works if you don't do that also. Can you tell me why you chose to do private in this situation? And do you usually do that when setting up a class or not?
Steve, that's a really good question. The private variable means it's only accessible to the methods inside this class. So these methods here can read and change these. Stuff that's external to the object cannot. Now, the reason that is we want to have a layer of control. So I mean, hypothetically, I could say public on this, but that means from outside of this file, I could change the main ingredient without using the set method. The preference is that I use the method to do it because then I can feed it a parameter.
Okay, so it's a preference then, and it's more of a safety thing than to make sure. Because outside, if you change this, you could effectively break your well, you wouldn't break the program, but would do things you didn't want it to.
Precisely.
Okay, got it.
It's a level of control. And
okay.
In some cases, sometimes you will make these methods private too. Sometimes methods will be private to an object as well. In this case, it doesn't make sense because we do want to send back information. We want to set information. We just don't want people to be able to directly access the variables. We want to have a layer of control. Maybe the layer of control also, like if somebody types in a price, maybe part of the setting the price is rounding it or doing some math to it or doing a markup on it or adding tax or who knows what. So sometimes there's additional steps that happen that a user outside the method might not even know.
Okay, so in general practice, then we should practice doing this and then just go public if we choose to do that in that case. Okay.
Yes, exactly. The general rule of thumb is that in a class file like this, all these variables should be private, though. The methods, typically public for getters and setters, but other methods will then have sometimes private depending on their function. All right, let's move on to the test portion of this. So I'm going to read the next little piece. Create an application named test sandwich that instantiates one sandwich object and demonstrates the use of the set and get methods. And so let's go ahead and do that piece of it now. And this one will be actually pretty darn simple. So right inside the same folder here, I'm going to right click, create a new class file. Now it's important to state here that these do need to be in the same folder as part of the same project and package in order for these two files to see each other. If they're not in the same location, project and package and folder wise, they will not talk to each other. Then you have to go through like special routines to make them talk to each other. And so as long as you're in the same folder, project and package, there'll be no problem. We'll call this test sandwich. We are going to create a public static void main because we do want it to execute. And so it'll do the hard part of the work for us. Now, in order to create a sandwich from the class file, from the blueprint, we will call upon the sandwich class. Because it's in the same folder, it will say, well, hey, it will be okay because it's in the same folder. And I'm going to go ahead and just create my first sandwich here, and you can call it whatever you want. And we're just going to use the keyword new sandwich. And this is called instantiation, by the way. We are calling upon the sandwich class, and this creates a blank object. This statement does. We're not sending anything to it, but it creates the object waiting to receive information. The next step will be with the name we just gave this object. So it's become this unique object now called first sandwich. We are going to set the bread type. Now I want you to notice what happens here with Eclipse. And this is showing you the connection between the two files. This recognized that I created a version of sandwich. So it went to this file and said, oh, you're making a sandwich. All right. What are you calling it? First sandwich. All right. So whatever this thing is, it has all the features that are listed here. It has these methods and these data fields available to it. So since this is recognizing that sandwich is in the same folder, it's going there. And as I start to type first sandwich dot whatever, in this case, I'm going to set the bread type. It reads from the other file the methods that are available that match. Isn't this crazy, right? So I can just choose it from the list. I'm going to let's set the bread type first. And I'm going to put in rye. Okay. Oops. Sorry, I thought I was hitting my arrow key and I'm hitting my 0 key. All right, then we'll go to the next line here. And for that same first sandwich, I'm going to now set the main ingredient. And what's my main ingredient today? What's good on rye bread? Corned beef? Corned beef on rye sounds wonderful. And then we're going to set the price. Once again, I'm going to say first sandwich, set price. And now here I will hard code a double. So let's call it, I don't know, $6.99 for that sandwich. All right. Now we're just going to test it and see if that worked. So we created the object, we set the bread type, the ingredient type, and the price. And now we're going to see if that actually worked. So here's how you test it. We're just going to do a system.out.println, and we're going to do the following statement. All right, so you see this is fighting me here. Sorry. Let's get our double quotes in here. And let's say you ordered, if that's what they're doing indeed, And this is where we pull the information back. So we're going to say first sandwich dot get main ingredient. We're going to add another line to this. I'm going to bring it down to the next line and concatenate. So this statement is going to the object, going to the method, get main ingredient, and returning to us whatever is set there. That's what it's doing. And so that's going to drop in as text on, well, what kind of bread are we on? Well, let's see. Let's first sandwich get bread type. And that will return from the object the bread type. And once again, we will concatenate. And you know what? Let's go to the next line here. Which, right, and it doesn't like us to do that, but hey, we're going to do it anyways. Which costs, and you can do your formatting here if you wish. And now we're just going to say first sandwich dot get price. Right. And so if it worked correctly, the stuff that we set here is going to be redisplayed here. Right. We're not prompting the user for anything. We're just manually hard coding this stuff. But you could easily imagine that this might be the front end for maybe a cash register application, right? Where you walk up to, the register and you say, I'll have a corned beef on rye, with Swiss cheese and mayo and pickles and whatever. And all those things could be objects that are part of the class file. And then as they press the buttons on the cash register, it builds into the object. And then when it comes out, they print it on a receipt. Where does that come from? It comes from the program that they write. So this is actually, despite the fact that it's very simplistic, is really kind of like the precursors to writing something significantly more complex. We're hard coding values just to see if this is working. And this is all you have to do is do it once, by the way. So you could save this file now and go ahead and execute. So hopefully it'll work. So let's run this. All right. All right, well, my formatting's not that great. I should have put an extra space here. Let's do that one more time. Oops. No. Okay, so that one's still running. You got to turn that one off. All right. Save the changes, and let's run it again. You ordered corned beef on rye, which costs $6.99. You want to test to see if this is working again? Copy all of the code. Call it second sandwich. You got to do your copy and paste. It's better than me, though. Change the ingredients, by the way. So on all of these, you have to change it to second because we're creating a new object now with its own properties. And maybe with this one, it's on, let's come up with something a little bit more exotic. Like, how about this? Sourdough, right? And then maybe instead of corned beef, it's, I don't know, give me a flesh type. Maybe it can be vegetarian. Maybe it could be tempeh, something like that. And of course, because it's a specialty sandwich, it's very expensive, but delicious, very delicious. So let's see if this worked. And if it worked, now I should have two messages. And what this is showing you folks is that we are creating two unique objects each time we do this. These values, when we set them, get embedded into the object, and then we can get those settings back. Okay, this is very simplistic, but it shows you that, this serves as our blueprint. This is our actuation of the object, and this proves it. And then we do it twice to make sure it works. I know the exercise says do it once, but when you do it twice and you create a second object, you really see the difference. All right, so that's the sandwich one. That was number 11. Let's move on to the next exercise because we are running out of time and quickly. All right, so this one's got three steps to it. And then the first step says create a class named student that has fields for an ID number, number of credit hours earned, and number of points earned. For example, many schools compute grade point averages based on a scale of 4. So a 3 credit hour class in which a student earns an A is worth 12 points. Include methods to assign values to all fields, all right, which is a tip, right? So you got to have setters for all the fields. A student has a field grade for grade point average. A student also has a field for grade point average, including a method to compute the grade point average by dividing the points by credit hours earned. Write methods to display the values in each student field and save this as student Java. So really what we're doing is getters and setters and an internal method which allows us to do some calculation. So this is going to ramp it up a little bit. This is going to be called student. So let's get to that one here. All right, so let's start with the basics. Let's create a new class file. This one's going to be called student. No public static void main here, folks. Not necessary. We were given private field names to including a private variable for an ID number. What kind of numeric data type should that be? How about an integer? All right. I think your ID numbers usually don't have decimal points, right? So I'm going to say ID number. Another one would be the number of hours. So we're just going to call that hours. That's also an integer. And another one for the number of points. Right. So those are the data fields. We will need getters and setters for all of these. So this is a really good way to proceed when you're doing this work, by the way, is you'll begin by putting your data fields in and then generating your getters and setters right off the bat. So I'm just going to right click. I'm going to choose source and generate getters and setters. Index out of, oh, okay. So it's telling me I got problems here with my stuff. Why is that? All right, did I forget to save? Let's save. So see, I was having this problem in the earlier class too. I couldn't save my file, and my only way to save it was to close it. So this is a glitch with Eclipse apparently, and then reopen it, and then it's saved. All right, and look what it did. It didn't save my work. All right, so now I got to recreate it. All right, not a big deal. Private int ID number. So something was glitching there, and whatever it is, it was not unusual because it happened in the previous class. So I have to investigate the why on that. The hours, and another private for the points. Once again, I'm going to try to save my work here. Okay, this time it worked. So if I right click and then do my source, getters and setters. Oh. Aha, okay. Now let's do it. Select all the fields and say okay. And now we have getters and setters. Now it did the same thing as last time. It put these two privates at the bottom. I'm not sure why it's doing that. It's being kind of goofy. It really should be displayed like this. Now we have our getters and our setters. There's another portion of this application that we're going to get to where we're going to create a constructor. And we're not doing that in this initial step, but that is an important step. But that happens in part C if you're curious. All right. The part that we did get asked to do now was to include a method to assign values to all fields. We did that. Write methods to display the values in each field. We did that. Those are the getters and setters. It's the in-between one. Include a method to compute the grade point average field by dividing points by credit hours earned. All right, so that's the next piece that we're going to do. So I'm going to go back to the method, and now I'm going to choose to add this method to the top, by the way. And the reason I'm doing that is because the getters and setters are kind of givens. It's okay for them to be at the bottom. I probably never need to look at them again, frankly. But this particular one should be a public method because we want to be able to get this from outside of here. It should return a value, And because I know we're doing division with hours and points, and I know how GPAs work, that usually it's like, very rarely is it like 4, right? It's 4.0. That's how we say it. So it needs to be a double to get the decimal in there. And then we need a name for it, which is, you can name it a number of different things, but I'm going to actually name it with a get name, because from an external standpoint, I'm going to ask get the grade point average, or get grade point is what I'm going to ask for. So it will pull that back. So in my mind, the word get means to retrieve. I could also call it calculate grade point. That would be valid too. But get to me tells me I'm pulling a value back. So that's why I use that term. All right. And that's kind of a convention in programming, by the way, folks. So with the get grade point, we don't need to send it any values because the values are built in to the object. All we need to do is the calculation. So kind of going back to this whole return statement thing, I'm going to go straight to the calculation, where I'm going to take whatever points are embedded in the object. I'm going to multiply those by 1.0. Why do I do the 1.0 multiplication?
Is that to ensure that it returns a double?
Correct. I'm casting it. This is called casting to a double. So by multiplying by a decimal number, points becomes a floating point number also. It changes from integer to a double. And then I'm going to divide by the number of hours. All right. So that's all it takes to do that calculation. If you're wondering as to why, if I just used simple integer division, it would truncate the decimal places. So, and in fact, maybe I should say y multiply by 1.0. That's the answer. If you want, you want to just take notes on it. All right. So we have that part complete. So we have part A is done. The file is created. The class is created. We need to save it. I'm doing a Control S to save. I'm scrolling through and I'm looking for highlights or underlines. I don't see any. So I think we are okay. All right. Now we're going to move to the next step. So let's take a look at the next set of instructions, which is write a class named showStudent that instantiates a student object from the class you created and assigns values to its fields. Compute the student grade point average and then display all the values associated with the student. Save the application as showStudent. So that's our next step. So I'm going to do this, and I have my eye on the clock, so I'm going to be doing a little more copy pasting than I am typing at this point, by the way. So let's go back to Eclipse, and I am going to right-click the source folder and once again create a new class file. This is going to be called showStudent. This will be an executing program, so it does need a main method, so we're going to pre-create that. And we have the basic part of our program set to go. The first part of it is to instantiate a new student. So I'm just going to come in here. I'm going to call upon the student class, give the object a name, and I'm just call it pupil. And maybe we'll call it pupil 1, noticing the difference between the L and the 1 this time, right, you guys? And how those look so similar, but they're really different. All right. And then what I'm going to do, and actually I won't call it pupil 1, I'll just call it pupil. And the reason I'm doing that is because I want to copy paste. So I'm then going to go ahead and set the ID number, set the points, and set the hours. Okay. Then I'm going to call another set of methods to show all of those things. Oh, but I didn't write that, did I? I love this stuff, you guys. All right, so we didn't do this part of it. So it says include a method to compute the grade point average and write methods to display the values in each student field, which we didn't do. All right, so I'm copying code that I didn't complete. So here's what we're going to add to the class file that I forgot to add because I was being so darn hasty. In the class file, itself. So going back to student, what they wanted us to do is to be able to get the values. The get values will still apply, but rather than calling them directly, they wanted us to write methods that also did some display work to make it look pretty, that look like this. So if you guys really quickly screenshot this or whatever you do, whatever your method is, here are those methods. And I just want to show you that these will show those particular values. So we're calling it show ID, show hours, show points, and those will just spit those things back on the screen. All right. So now that I've created those, I'm going to save them into the class file. And now over here, those underlines will go away. So these methods will show those values on the screen. So this is a different way to do it, basically. All right. Finally, we need to do a method, excuse me, a statement that's going to put the stuff back on the screen. So I'm going to say system out print line, the grade point average is, and if you want to save a little bit of screen space, this can move down here, sort of like this. And then this one will get the grade point back. So the pupil get grade point and we'll turn the value. So let's go ahead and save this and run it. And so notice how we're reiterating the ID number is, the points earned, and the credit hours. Those are all being returned exactly as entered. And the grade point average is 3.13, and you can verify that with a calculator if you choose. Right? You could also format it, make it look nice, round it, do all those things. That's really kind of on you. You want to test to see if this works again by putting in different values. Does it really truly work? You can just come in here and just call it pupil 2 on all of these objects, as long as it's uniquely named. Put in some different values. And run it again. Save it, of course. And so if you look at the output now, you will notice that it did it twice, right? And that the values that I put in did carry, and they did calculate. Boy, this guy's a really good student. That's not a possibility, obviously, but hey, those are the numbers I put in, and that's what came back. So that's not really technically possible. But this would be part B of exercise 12. The next thing that we're going to do is we're going to create a constructor for the student class that we created. The constructor should initialize each student's ID number to 99999, his points to 12, and a credit hours to 3, resulting in a grade point average of 4.0. So by default, that's what we will preset. Write a program that demonstrates that the constructor works by instantiating an object and displaying initial values, and save it as a different program name. So I'm going to leave this program alone, show student, and then I'm just going to go ahead and create a new one. And sometimes I do save copy as. This time I'm just going to create a new class file and just call it show student 2, because I'm just going to copy and paste it all in anyhow, by the way. I'm going to create a public static void main. Boy, it didn't pick up my source folder here, so I'm going to recreate that. I'm not sure why it didn't pick it up. Now it did. So public static void main and show student 2. Let's go ahead and create that. And now we're going to do a little bit of copy pasting, given that we're already past the end of class and I want to get you guys going here or going home. And so what we're going to do here now is, once again, we will call upon the student class to create this. However, it did tell us to add a constructor here, which is a really common part of class creation. And so we need to add to this class a piece that we don't have yet. And that is a method named the same as the class file we're creating. So this will be public. That has to be public. And we're going to name it the same as our class, but as a method. And this is called the constructor whenever we do this in a program. And in the constructor, if you are presetting values, this is where you do them. So sometimes you leave the constructor blank. And if you don't include a constructor, by the way, a blank one is assumed. if you're wondering. But if you need to set values, you would just simply do something like this. I could preset 99999. I can preset the points to 12, just like we were told to do. And the hours can be preset to 3, just like we were told to do. Okay, that's the constructor function. I am now saving it. So what this is really saying is if I call student class like I did here, and if I did not do these steps, those values would be preset to these values instead. I can prove that here by simply eliminating in pupil 2, by simply eliminating those lines of code. And now as I run this, I want you to notice that the second one, even though I didn't declare any of those amounts, are being pulled back by the default values that I set. Okay, so now in this class, we have now created a new student again, but this time we're just going to go right to those other methods. So we're going to do the show of all the stuff that's built in, and we're going to see the same thing we just saw basically, and then also the grade point average once again, like so. So let's run this now, save it and run it, and you'll see that it will automatically pull back those default values. So that's really the demonstration here. And so when you call the constructor function, you're not passing anything in, it will automatically come here and say, well, the default values are this, and assign them. Other constructors will allow us, and we're going to see this in future assignments and chapters, by the way, where we can pass values in to the constructor and assign these as we're creating it. But that's a later skill. We're just trying to get the basic operations working right now. All right, I'm going to end the recording here because this is actually complete. And I'm just going to do this first. So here's the completed student class file. So I'm going to scroll through it. So through line 26, 26 through 51, and the bottom. Show student, and that's in its entirety, I think. Maybe I can zoom out a click or two and get it all on screen. And then show student 2, it's in its entirety, completing all 3 pieces of exercise 12. All right, folks, this video ends here, and then we can take questions.